All right, using files for data storage. This is another thing that would have been fun to do earlier, so that we've been using files more often than the whole semester. Instead, we've just been using keyboard input. So what are files for? For permanent storage. I mean, as permanent as a hard disk can be, right? You know. So you wouldn't want to type in, 10,000 census records, for the state of Midwest City or whatever, and then have them all lost as soon as you quit your program. You'd instead want to store them out to a file. You wouldn't want to have to type in, weather patterns for, 100 different days each time you ran the program. You'd rather type them in once and then read them in each time you needed to run your report. So you can use files instead of keyboard for program input. And you can use files instead of the monitor screen for output. It allows the data to be retained between program runs. So your general steps: I'm going to open the file, I'm going to use the file, you can read from it, you can write to it, or both, and close the file. So if you need a file, what you do is you #include fstream. Fstream's for files. There's two different kinds of file types. Well, there's three really. Input files, ifstream, right? So if fstream means file stream, ifstream for input. ofstream for output. And if your file is going to do both input and output from a file, which is a little bit more sophisticated than what we're going to do, then you would use fstream. Now there are other ways of accessing files than using these classes. Just like we've seen more than one way of displaying data, right? We were using printf. We use printf. We use cout. Two different ways, two very different ways to accomplish the same thing. The cool thing about file streams is that once you have the file created, writing to it is as easy as writing to cout. And reading from it is as easy as reading from CIT. So for example, let's go ahead and just make a new project and run with it. I believe we're on R. R is Romeo, right?
Yes.
Okay, so empty project, Lecture R.
Our next one's Sierra.
I think we're going to get past Z. Alrighty, so Lecture R is a C++ file.
Alpha.
Yeah. Or we're going to hexa alphabetical. I don't know. Okay. So at the top of our boilerplate, we're going to, or I'm not going to change the boilerplate, but if we did, we'd add something new to it. #include fstream. Just like iostream, but for files. Now I'm not sure we're going to be using files each time, so I'm not going to add that to the boilerplate, but if I wound up doing so, I would. Add a new item. Lecture R. Boilerplate. All right, time to add a new one. #include fstream. I'm not going to say hello anymore. I'm going to say Lecture R. File IO. All right, let's make a file. It's going to be an output file, which means it's going to be an OF stream space, and I'm just going to call it FOUT for file out. You can call it anything you wanted to. Now that's not its name. That's just the name of the variable, right? That's not the file name, but we're going to need a file name, whatever file we're going to write to. So when you're ready to open your file, if you remember in Python, this is what you did. This isn't Python, but you did that. In file is equal to that, comma, quote R, right? That's how you opened a file. It's very similar in this language, except instead of in file equals open, you do in file dot open. And then you give it the file name. And you don't have to specify the R, because since it's an IF stream, it knows it's opening it for reading. But we're writing to a file. So let's go and let's create a variable to hold our file name. We could ask the user, save to what file? But just to save time, not have to answer everything every single time, let's call this output.txt, or output q, because since this is lecture q.txt. Semicolon. I forgot the semicolon. That's why it's underlining the next line. All right, let's open our file. fout.open, parentheses, fname, in parentheses. Let's write some stuff to it. fout less than hello backslash end. And let's close it. fout.close, parentheses, in parentheses. Now when we run it, it's going to create this directory, this file, out in whatever directory our code is in, which is probably not what we really want, right? We'd probably rather to save it to the Windows, the users directory, or ask them where to save it. All right, we don't see that it did anything with the data, right? We're not getting any messages, but at least we're not getting any error messages. You always want to call close, and you want to call it as soon as you're done using the file. The reason why is that as long as your file is open for writing, it's locked and nothing can happen to it, right? Like if you needed to move your folder to a different, or upload something or whatever, if that file was still held open by the program, you couldn't do much with it. Couldn't back it up or whatever. So now that I've run it, I can go out into my directory structure and find it. So I'm just going to come over here if you're using Windows. If you're on a Mac, you've got to do something else. And in fact, if you're on a Mac, I'm not sure how you find where this file is being created. Right-click, open folder in File Explorer, and there's my output file right there. It's a TXT file. I double-click it, and there it is. Hello. Let's make a great big file that's 1,000,000 hellos long.
Oh boy.
So instead of like that, for parentheses int I equals 0, I less than 1,000,000, which is a 1 followed by 6 zeros. 1, 2, 3, 4, 5, 6. I plus plus. Or maybe instead of writing out hellos, let's write out those numbers. Cout less, except it's not cout, it's fout. We're writing to a file. Less than I, less than ENDL. And then let's just display a message saying that we saved our data to a file. Data saved to, and what's our file name variable? fname. So data saved to space int quote less than fname less than ENDL. Just so that we see that something happened, right? It's taking a while, but it's writing out 1,000,000 numbers to the file. Maybe that was a few too many. There, it finally did it. So if I go back and I open that directory again, right-click, open folder in File Explorer, double-click on Output 2. See, it's pretty large now. It's 7 megabytes. I double-click it, and it's got all those numbers in it. What if I wanted to open that file automatically, rather than having to go and edit it by hand? Well, I could use a system call to do that. but not system pause. And this is only going to work on Windows, so for the people who aren't on Windows, you may as well not even bother doing this. You could add them, but comment it out. I'm sure you can do this in Windows, but not with the commands I'm about to give you. We need to build a system call. But it's not going to be pause. It's going to look like this. Notepad followed by the file name. Right? That's the command that I wanted to execute. So I need to build a string that says system parentheses quote notepad space file name. Let's see if we can do that. So string S command for system command. S command equals quote system parentheses notepad. Wait, I forgot a quote. How about backslash quote notepad space end quote plus the file name F name plus quote backslash quote I've added too much to it. I don't need the word system and I don't need the parentheses. It just needs to say that quote backslash quote notepad space end quote plus F name plus quote backslash quote end quote. Anybody remember what quote backslash does? I bet somebody knows and they're just not saying. Quote backslash is so don't type this. I'm going to wind up deleting this. But if I had to do this, like I said, don't type this. My name is Joe. There's a problem with that. What's wrong?
The string's not complete.
Right. The reason is because the string ends right there. So we got to fake it out. Oh, that's not really the end of string. And so this means it's a slash. Excuse me, that means that it's a double quote. And so that's what we're doing here. Let's print out our S command just so that we know what it looks like, right? Make sure that it looks reasonable before we actually try to execute it. Oh, I'm going to make that shorter than 1,000,000 now, right? I'm going to take off a couple zeros.
Let's make it 100.
1,000 won't take very long. There we go. Okay, this looks good. Notepad output queue.txt. I think that's good. I think that's what I wanted to do. So let's call system with that command. System S command. And it should call notepad and it should edit that file. And system isn't liking S command. It's complaining that we're giving it a string and it doesn't want a string. It wants a character array. It's being very picky. So what we're going to do here is we're going to do command dot C_str parentheses in parentheses. A lot of trouble, but the nice thing is now every time we run it, it opens our file. And you'd have to do something else to get it to work on Mac or Linux or something like that, but for the Windows users, it's pretty nice.
Can you go up real quick?
Wait, is that in the while loop or is that at the very end of the code?
That's at the end of the code because I don't want to open it 1,000 times.
No one does.
Okay, so that's all of our code except for the boilerplate up at the top and the system pause at the bottom.
Yes.
We had to have that line added to it to get the file stuff to work. code. This is legal, but if I wanted 2 lines of code, you know, like x equals I or whatever, that's not going to work because there's no braces. But there's nothing wrong with using curly braces every single time. If you like it, if it makes you feel better to do that, and I'm not being sarcastic, quite often I'd say that that's actually the best thing to do. It's just that usually I'm trying to put as much code on my screen as possible to make it easier for y'all to type without scrolling up and down so much.
I do think I screwed up though.
All right, so if our file fails to open, and why might it fail to open? It doesn't exist, right? Or the hard drive has become disconnected. Or it's on a disk that's been ejected. Not that anybody uses floppies anymore, but right? You know, there's all sorts of things that can go wrong. So if we tried to open our file and it failed, then we can check to see if it failed, because we can't continue reading from the file. Well, we don't even have a file that we're opening for reading, but we just created a file with 1,000 numbers in it. So why don't we open that file and add those 1,000 numbers up, or something like that. So open the file we just created, read all the numbers, and sum them up. Since it's for input rather than output, we're not going to use OF stream, we're going to use IF stream. And since it's for input, I'm going to call it FIN. You're probably picking up the pattern. C out, F out, CIN, FIN. That's just my personal choice. You don't have to call your variables that. So IF stream space FIN. We could just reuse the same variable, right? We already have one called fname, or we could ask the user to type it in, right? Open what file. We could have asked the user what file we wanted to save to. That would have been pretty cool, right? We could have asked them, save to what file. We might want to do that. Let's go up to the top here and ask the user. Of course, then we're going to have to type this in every single time we run the program, and we're going to get real tired of that. But save data to what file name? Question mark. Backspace space greater than end quote semicolon. And then CIN greater than fname. That way we can specify what file.
But here's the thing, you can save it to output key.test.
Yeah, I don't need that anymore because they're going to be typing in something, so I could delete all that. All right, down here we have ifstream.fin. We need to open the file now. fin.open parentheses fname in parentheses semicolon. But we need to check to see if it failed. It might fail if the file doesn't exist. Now we're sure this file exists. We just created it. But under other circumstances, it might not. So if
Or your hard drive just says, hey.
Yeah, if we just filled up our hard drive, right, we're trying to run it. So if not fin, or you could use if fin dot fail. I like that one better. I like that syntax a little bit better than what they're telling us. So I'm going to go with it. But that's how they do it in the textbook. Your choice. So if it failed, we're going to display an error message. Cout less than quote, could not open, end quote, less than fname, less than ENDO. Else, it worked. So let's go ahead and read our data in. And they show a specific syntax for reading the data in that I kind of like. So as soon as we're done, as soon as I don't hear any more keystrokes, I'm going to go and look at it. while input greater than number. That looks kind of weird, but it works just fine. So we need a variable to contain our data. These are numbers, right? So double number or value or something like that, right? And then while fin greater than value, while we read from our input file, and that succeeds, we're going to add that to our total. Now I forgot to create a total variable. We'll do that in a minute. But let's print out what we just read. We just read space in quote less than value less than ENDL. And here we need to close our file. So fin.close, parentheses in parentheses. Actually, if the file failed to open, then we don't need to close it here. We need to close it in here. But I'm going to leave it where it is. All right, save to what file name? I'm always going to use .txt so Notepad will work. If my file name doesn't end in txt, I'm not sure that Notepad will work on it. It might. But like, what if I typed in whatever? Oh, it did work. Cool. Alrighty. And then when I close it, it reads in all the numbers from that file. So our code's working. But it's not adding the numbers up. We need a variable that'll hold our total. So double double place total equals 0. Yeah, my lips stopped working there. And we're going to add value to total. Total plus equals value. We might also want to keep track of the number of lines that we read, right? So maybe we need another variable to contain the number of lines. Int num underscore lines equals 0, semicolon. So I just added these two lines here. That one got added, and please don't add all these slashes. Those are just to show you what I'm changing. And then I did this, and then I incremented number of lines, num underscore lines plus plus. Why am I doing that? So that I can just calculate the average if I want. After the while loop is done, that's where we should close the file. I'm going to delete this fin close and move it to right as soon as the while loop is done. So I'm deleting that, and I'm moving it to after the while loop. fin.close. Always close your file as soon as possible, as soon as you're done reading from it or writing to it. And now I could print out the average. I'm probably going to comment out this cout statement, right? I don't need to print out 1,000 or 1,000,000 numbers or stuff like that. So I'm going to comment out that line. I may even delete it entirely. It would have been nice to tell them we were reading, though, right? So right here at the top of our else body, cout lesson quote reading from space end quote lesson f name lesson ENDL. There we go. Right, because if it was 1,000,000 line long, it might take a long time for the while loop to finish, and it's nice for the user to at least know something's happening. All right, after the file is closed, we can calculate the average. So double average equals total slash num underscore lines, semicolon, and let's print those two things out. Cout less than total equals end quote less than total less than ENDL. Then cout less than average equals end quote less than average. less than ENDL. If we get tired of it popping up that file in Notepad, we could always comment out that system call, right? Right there. We don't have to do that. We could comment out these 4 lines. I'm going to add a comment. If you don't mind scrolling up, you could do it too. But where it says string S command, if you want to scroll up, you could say create a system command to open the file we just created. This only works on Windows. Not because Windows is special, but just because I don't know the name of the files, the commands that you would have to execute for the other operating systems.
But most business computers are going to be Windows anyway, unless it's a graphic design business.
True enough. A lot more Windows computers out there, but there are a lot of Mac users too. But yeah, the graphics people and the musicians and the web designers, they're more Mac-y. But sometimes I have like several Mac students in a class. I'm surprised I haven't had very many in this one. Here we go. Save data to what file name? t.txt. Data saved. I'm going to close my file. And that's the total of all the numbers, and that's the average. And that sounds good, right? Because adding up all the numbers between 1 and 1,000 or whatever, the average would be about half of them. Looks a little bit funky, but sure it's accurate. All right, we know how to save data to a file. Why don't we save these results to a file and pop it open? So we're going to need another variable, or we could just reuse the one we have. OFStream output, I'm giving it a different name just for variety. Output.open quote report.txt end quote in parentheses semicolon. That's going to be the name of our file. And let's write these messages out to it. Just copy those 2 lines right there. Copy, copy. Paste them and change the couts. It's no longer cout less than, it's output less than, output less than. And would it be fun to do the Notepad thing again to open our report? I think so. So I'm going to go and copy and paste those 4 lines of code, put them in here. With a minor change. Got to make a change here though. Sorry to backtrack on us, but you see where it says report.txt here? I'm going to come under this OFStream output and make this say fname equals report quote report.txt. You see what I did? I just added this line. I inserted that line. And I'm going to make this output.open say output.open fname. Just to kind of be, you know, for synchronicity with all of our other open statements we've seen. Now, as promised, I want to open this file up in Notepad. And so I'm going to come up here and grab those 4 lines, maybe even the comment. Just grab your string S command equals blah, 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 and come and paste it here. But we haven't closed the file yet. We wouldn't be able to open a Notepad if we haven't closed it. So output.close, parentheses in parentheses semicolon. and then paste. That should open our report. Save to what file name? t.txt. There's our data file. I close my data file and it opens up my report.
So, after you do the output average, what do you have to copy and paste?
What I did is I went up and I grabbed that system command stuff, string S command.
Oh my god, who the heck cares? Why so mean?
All right.
I think it might be administratively locked.
And here we are ending the lecture because the code failed for half the students in the class. Dadgummit. Alrighty, so we're done. We're done.
Dadgummit.
Come on, man.